Hi all, today we are going to see about the topic projections, which comes under 3D viewing visible surface reduction unit. So this is one of the major concentrated topic in the computer graphics. So this plays a major role in depicting the graphics. Hi all, in the previous video we saw about the what is projection and the types of projection. So now we are going to see a particular type of projection, that is parallel projection, in detail. Okay, so what is parallel projection? When my imaginary lines, that is projectors, is parallel to the view plane, then that is called parallel projection. Okay, so we saw that in a type of projection video itself, previous video itself. So in parallel projection, the distance of projection plane from the center of projection is infinite. So consider this one. So consider this diagram. So my object is somewhere else. So my view plane, that is projection plane, is somewhere else. I'm going to project my object's vertices into the screen. My object is somewhere else and screen is somewhere else. So the distance between projection plane from the center of projection is infinite. Okay, so this is why the first point is given, stated as so next we can specify the direction of projection instead of the center of projection. So we are going to specify the direction of projection only instead of the center of projection point. So here we can connect the projected vertices through the line segment. So object is somewhere else and my projection plane is somewhere else. So I'm going to connect my projection vertices with the help of a line segment. The parallel projection eliminates the z coordinate. Here we are not going to consider the z coordinate, only x and y coordinates we are going to consider here. So in projection we are going to consider only two coordinates, one is x and the other one is y. Okay, so the parallel planes from each vertex in the object are enhanced until the lines intersect the view plane. So these are the characteristics of parallel projection. So in parallel projection, the projection lines are parallel to each other. The projection lines are not only parallel to the view plane, it is parallel to each other in order to depict the 3D image as such into the screen. So in order to project a realistic image, the projection lines are parallel to each other also. So there is a least amount of distortion within the objects. So there is no distortion among the object. As it is in the real time, the object will be depicted into the flat screen. The distortion amount will be less. The lines that are parallel to the objects are also parallel to the drawing. So this is the third point or the third characteristics of the parallel projection. So the fourth point is the view of parallel projection is less realistic because of no foreshortening. So the parallel projections are good for accurate measurements. So when we need accurate measurements, we can go with parallel projection instead of perpendicular projections. So next one is types of parallel projection. In parallel projection we have two major categories. One is orthographic projection and the other one is axonometric projection. So in orthographic projection, when my projectors or projector lines is perpendicular to the view plane. Projector lines are nothing but it is an imaginary line which is going to connect my realistic object into the screen. So when that line is perpendicular to my view plane, so then that is called orthographic projection. So further, the orthographic projection is divided into two parts. One is multi-view, the other one is axonometric. Okay, so multi-view orthographic projection. So in multi-view orthographic projection, we can represent two-dimensional orthographic image into a three-dimensional object. So in this we have to consider an object and we have to concentrate on several views of that object. For example, if we consider an object, we have to consider the top view of an object, then again the front view, and both the side views also concentrated, and by combining those views we get a realistic 3D object into the screen. Okay, so this multi-view orthographic projection includes front view, top view and side view. By combining these views we get a realistic image into the screen. So axonometric orthographic projection, it is used to construct the pictorial representation of an object. Suppose if we want an object's a pictorial representation, we can go with this projection. So here the sight lines are perpendicular to the projection plane. What is projection plane is? It is an imaginary plane which is going to map my surface plane with the imaginary objects, realistic object. So this is an imaginary plane. So the axonometric projection, orthographic projection includes three types. One is isometric, dimetric and trimetric. So in isometric, we can represent the three-dimensional object into two-dimensional drawings visually. So the angle between the two coordinate is 120 degree. So this is the difference in isometric and dimetric. So the angle between the two coordinate is 120 degree in isometric. So when we consider dimetric projection, the view direction of the two axes are equal and the direction of the third axis is defined individually. So we are going to define the third axis individually, but the view direction of the two axes are equal. So in the trimetric projection, the view direction of all the three axes is unequal. Okay, so the scale of all the three angles is defined individually, but in isometric, the angle between those three are defined as 120 degree, but in trimetric, the scale of all the three angles is defined individually, not default.